Yeah, hello guys. I'm back again with a new video. So in previous video we have discussed about Java programming and why Java, how Java works, of content, and about JVM, JRE, JDK, and we have discussed about the compiler and interpreter differences, and we discussed how Java executes. So I last video I have told that. We will make a separate in detail video of every topic to cover the basics and to understand in much better way. So today I would like to discuss about compiler versus interpreter. Generally, everyone gets doubt on this topic. So why do we use compiler for some languages? Why do we use interpreter for languages? And even some of the viewers might not know even what is compiler and interpreter. What why people used to say to compile the code, and why after only compilation we can able to see the output. Why can't we see directly? So these are the common questions from learner's side. So I would like to clarify this in this session. So let me show you a PDF to clarify all these doubts, and I will explain you about this content, and I will share this PDF to you if you want it. Please comment if you want this PDF to be shared. So today's topic is compiler versus interpreters, the core of code execution. So what is program? So generally, now I am talking in which language? English language. So if you know English, you will understand what I am saying. So if you don't know English, or if you know only Hindi, you might not understand what I am saying even if I am saying a simple statement. So if I told you to bring the water, if you don't know English, you can't understand, you can't respond to my statement. So such a way we make some communication using language. So generally, to instruct a computer, to instruct a machine, how do we generally instruct? So we all might know in our schooling that computer only understand binary code, zeros and ones. So in this programming we call it machine code. So first, let me explain you the problem we are facing. Our computers only understand very simple low level instructions, zeros and ones. So we know that computer only understand zeros and ones binary codes. So how does the compute human readable code we write, Python or C, get turned into something the machine can actually execute? Have you ever anybody got this question in your mind that how we say, like if we are saying to print hello world, how system understand it? Because system can only understand zeros and ones, right? So how can that can be understood by the system? So this is the main question, the main problem statement we used to face in our beginner stage. So coming to the big picture, when we go, this video will explore two fundamental strategies. So compilation, interpretation are the strategies or methodologies to make computer understand what we are writing. So we are writing C program or we are writing Java program in English, right? In human readable English. Those are human readable statements itself. So how can that computer can understand these words and make convert into zeros and ones and execute the command or execute the task we have provided? So what we will cover in this video is we will dive into what they are, what how they work internally, architecture, why certain languages use one or both. So here is the point. So which language uses both compiler and interpreter? The language I'm teaching, Java. So exact flow of how C and Java program runs. So let's get more practical, let's get more understanding on this topic. So understanding what is high level and low level languages. Most of you people might know this concept, but I am explaining again. So high level language, these programming languages. These are programming languages designed to be closer to human language, making them easier for developers to read, write, and understand. They use familiar keywords and logical state structures. So high level language means our programming language. Generally, we learn in our colleges and courses. So these languages are mostly human readable, writable, and understandable. To purpose of this high level language is to abstract way the complexities of computer hardware, allowing developers to focus on problem solving and productivity. So why high level languages are introduced? So if computer able to understand zeros and ones, why can't we write zeros and ones? So if we generally write, we can write. In initial days, we used to program in zeros and with the binary code only. But why high level languages are introduced? Because a developer who is developing a software should focus on how the software should be and what are the logical, what are the problems that software is solving. So he must not interfere in how hardware involves computer hardware complexity. If he involves in computer hardware complexity, his most of the task will be on that only. He can't focus on problem solving and coding and uh, how to bring that productivity in that software. So coming to the low level language, these languages are much closer to computers native, where high level languages are very relative to me. So related to us, low level languages are relative to computer. They are very near to the computer binary code. Those are assembly language and machine code. Absolutely. So this is not our current agenda to speak about more about low level languages. Direct hardware interaction will be there and often used for operating systems, device drivers, or performance critical tasks, which is for what task hardware is more involved. We used to write low level language codes for hardware involved software or hardware involved technologies, because in embedded systems is one of the core subject that we used to write code in assembly language only, because it is it is hardware it is a hardware coding. So hardware coding should be very nearer to low level programming, where our software coding should have more focus on problem solving. We need to use high level programming. So this gap, so to make computer understand what we are writing, we are writing different languages, we are writing in different languages but same logic. If you are telling computer to print hello world, it should print hello world even in C, Java, or Python. So command is same, but the way we write the program is different. So to make this to make this communication easier, we have compiler and interpreters to to change this high level programming to machine code. So I think you all got clarity. If anyone got doubt, please comment in the video. So what is compiler? A compiler. We used to use compiler in C language. A compiler is a special program that translates entire high-level source code into machine code before program is executed. So a compiler, it's like if you have if you have ever done a C program get executed, we used to write that program hash include stdio int main or void main open the braces and printf hello world close the main function. So if we compile that, there will be no errors. Then we will get a exe file get we will exe file will get created. So the program is compiled but not executed. So exe file, before creation of exe file, the C compiler is converting this high level programming to machine code. So after the conversion only the exe file is created. So compiler creates high level program into machine code, converts high level program into machine code before the program is executed. So how it works? Compiler typically works in multiple phases. If we click on that compile button on your GCC that IDE, you will end up traveling through multiple phases. So what are those phases? Source code. First of all, you are having a source code. You are having that code, human readable program, myprogram.c. So front end. What deals with that? What compiler does now? We will understand. First, it undergoes with lexical analysis. Lexical analysis means the scanner reads the source code character by character, groups them into meaningful units. So if you wrote the int main, that breaks into tokens, like it breaks that code into tokens like key int, keyword, main int, identifier, operator, like it breaks into tokens. So next it will undergo with syntax analysis. Syntax analysis is parser takes the stream of tokens and checks if the form of valid grammatical structure according to the language rules. Language rules, as per language rules, it is following the grammatical structure or not. It will check. Next, it undergoes with semantic semantic analysis, checking for meaningful or logical consistency. This includes type checking, checking for undeclared variables, incompatible variables. This is like checking if the correct sentence actually makes sense or not. So lexical analysis, syntax analysis, semantic analysis. Next, intermediate code generation converts the AC2 into a simpler abstract machine independent representation like three address code. So these are the in between phases of the compilation. So coming to the back end, deals with the target machine architecture. So what machine architecture, if you are using Windows or if you are using Linux, it deals with that machine architecture. So it has two phases mainly. Code optimization improves the intermediate code for better performance, which is the intermediate code is created at intermediate code generation. So next, code generation translate the optimized intermediate code into specific target machine code. So here we got that machine code which is understood by the uh, operating system, assembly language, or direct binary system for your CPU. So language which understood by the CPU is the machine code. So linking, next up main process is linking. If you program uses code from other compiled files, object files, or external libraries, the linker combines all these separate pieces of machine code into single cohesive executive file. So machine code and external libraries used in this program and other objects used in this program, object files used in this program, will be linked together, and that will create a exe file. So after compile button, if your program loads and gives an exe file after successful compilation, that means it linked all the machine code create converted from high level programming to the machine code and other external libraries and it links all the object files. Now loading, operating systems loaders brings the final executable file into computer's memory so the CPU can start executing. So if you want to execute any program in our computer, we want to load into the RAM first of all. So after creation of this file, exe file, it loads into the CPU and starts showing us the output. The result of successful compilation and linking. Compilation and linking is executable file. So this is how the process of compilation we have done in C language. So what is advantages? It is faster execution speed. Its speed is much faster than interpreter. No compiler needed at runtime. If you created an exe file, then you don't need a compiler. Better performance optimization. So 1 second, I will charge the laptop charger is low. I will bring my laptop. Okay, the next point is smaller executable files often results in compact binaries, especially for embedded systems. These generally C programming used in hardware development actually. So if you are developing an IoT application, so if you know about IoT coding, like IoT applications coding, that will be done in C language only. So because of its, if you are programming any operating systems, so that will be done in C language only. Even the world got updated to Python, C, .NET, like such amazing languages, but we generally prefer for hardware structural programming C language only for its compiler design and its faster execution, better performance optimization. Coming to disadvantages, compilation steps adds development time. Changes require recompilation, of course, which can slow down the development cycle. Platform dependent executables. So it is a main problem. So if an exe file is getting created, it is getting created for its CPU configuration. So that means if the CPU, if the operating system got getting changed, that exe file will not work for other operating systems. So it is platform dependent. This is the main problem that we have noticed in the C language compiler. Harder to debug at runtime. No, yes, if you are developing something, you need to debug it. If you got an error, if you have to remove that error in runtime, right? Some of the projects, so that is not possible with the compiler here. So we got clarity about the compiler. If any doubts, I repeat again, if any doubts, you can comment on the video. So we are entering at the our game. Interpreter interpreter. So note point, interpreter, if you are discussing about interpreter, that means Java is not an completely interpreted language. Java is first compiled and then interpreted. We will see in next pages. So interpreter language, first we have to understand what is interpreter. An interpreter is a program that directly executes instructions written in a high language, translating and running each statement on the fly. So in previous video, I have told that interpreter executes the code line by line. So before getting in the interpreter, I will show you the architecture of C programming. So execution process of C programming. So if you want, you can screenshot this execution process: source code, pre-processing, lexical analysis, syntax analysis, semantic analysis, intermediate code optimization, and then CPU, assembly, linking, loading, CPU, execute instructions. This is the flow chart of the compilation program of C program. So in for Java, we will discuss it again. Imagine having a real-time interpreter translating, like one example, one analogy here. If someone is waiting for something to be done. So if I'm sitting here, my cook is cooking there. If after cooking it completed, I go and taste the food, his compilation. And after, like I was after cooking completed, I go and watch him, his compilation. While cooking, I am watching him is his interpretation. So like one real life analogy to understand much better how it works. So basically same way, generate and place an image for interpreter architecture. So, so this is not visualize, this is not the process. So read, the interpreter fetches a statement or expression from source code. It performs immediate lexical and syntax analysis, often building small temporary abstract syntax tree for statement. It then directly executes the corresponding action. It moves the next line. So it is executing that line and then moves to the next line. If something is wrong with that line, it shows us that there is a problem with this line. No separate executable. Unlike compiler and interpreter typically do not produce a separate standalone machine code file like exe file. The translation and execution happens together every time the program runs. You got the clarity? The translation and execution happens together every time the program runs. Advantages: faster development, platform independence. Yes, platform independence, because as long as interpreter is available for particular platform, the same source code can run on it without modification, because it is not depending on the CPU architecture. Whereas our C programming, during the phases of lexical analysis, semantic analysis, this, after that, intermediate code generation and code execution before loading, that we are involving, we are connecting, we are communicating with CPU architecture. So here there is no CPU architecture. Here we are having an interpreter for every platform, same interpreter. So no explicit compilation step, easier to debug best, because every line is getting, if you are getting error, every line it is showing that there is an error. When error occurs, the interpreters can often pinpoint the exact line of the code. Dynamic typing and flexibility, same point discussion. The disadvantage is always execution speed is slow, requires interpreter at runtime, less optimization opportunities, because it processes line by line. The interpreters have less opportunity to perform progressive. So line by line executions, we cannot understand, we cannot see that global optimization. If there is a long code, if it is executing line by line, we, after execution, after seeing long code, we cannot think of getting optimized. Code is visible. The source code must be present on the machine, which might be concern for intellectual properties in some commercial applications. Because if in C language, after exe file is created, there is no necessity of the code. But here, code is necessary. So why C compliant? Because why C language is compiled? As we discussed, design philosophy. For what purpose C language is required? In such a way, C language is designed. C was explicitly designed for performance, efficiency, and close to hardware interaction, like operating systems coding, IoT coding, embedded coding. In this programming, where the programming, the where we are, our product or our project is much related to hardware, much near to hardware, we are using C language there. We are using compiler there. Direct memory access, like pointers and manual memory management in C language, requires compiler to have precise knowledge of memory layouts and addresses, which is facilitated by compilation process. So it has more command on memory access. Performance criticality, execution flow. So I have discussed already this one. A C compiler translates C into object files, and then links them with necessary libraries to produce exe file. The operating system of every program that needs to be executed should load into the RAM by the operating system. This is a major point. This is an statement. This is a fact. Execute the CPU directly fetches and execute the machine instructions from memory, interacting with the hardware as needed. So why Java is both? This is the point that we need to come here. మీరు ఈ వీడియో క్లిక్ చేయడానికి కారణం కూడా ఇదే ఉండొచ్చు. Why Java is both? The right ones run anywhere. So you can write code in once, and you can run that code in any machine. Linux, Ubuntu. Ubuntu is a Linux distribution. Windows, Mac, you can run it anywhere. Java core design is that. Java goal is that to achieve platform independence. Platform independence is the primary goal of Java. A single Java program should run on any device regardless its underlying hardware or operating system. Any hardware, any operating system that need to be successfully run without any changes. Compilation. So why Java compile and so when after compile, so when we after saving a Java program, we use the Java C command to compile this code. Our Java source code .java is compiled by Java C compiler. Java C compiler is compiling our Java code. That compiler does not provide native machine code. Instead, it generates bytecode. This is a major thing. This is a primary thing we need to remember here. After compilation of Java program, successful compilation without errors, a bytecode is generated. Bytecode is intermediate low level platform independent instruction set. So this bytecode only brings platform independence to Java. This bytecode introduced platform independence to Java. So this bytecode is platform independent. After compilation of Java program, the bytecode is generated in .class file only after successful compilation. If a compiler makes a final book translation, bytecode is like universal instruction manual that any trained worker like JVM can understand regardless of their native language. This is small analogy. So we have discussed about Java virtual machine in earlier class in session. Next video will be on JVM, JRE, JDK in detail, in-depth analysis. So this video, JVM, Java Virtual Machine, is heart of Java's runtime environment. Of course, in last session we have discussed that it's software layer that acts as interpreter for Java bytecode. So first, it is already compiled. It is compiled into bytecode. Generally, in C language, after compilation, we are getting exe file. That is in pre step of the creation of exe file, we are converting it into machine code. Here we are not converting into the machine code. We are converting it into bytecode, which is a platform independent code, which is stored as a .java file. When you run a Java program, the JVM on your specific platform reads the bytecode from the .class files. The JVM then translates this code into the native machine code for specific hardware and operating system it's running. Just in time compilation. So this is something complex that Java is a hybrid structure. Java compilation and interpretation is a hybrid model. So during interpretation, when bytecode is already generated, during interpretation by JVM, if a code is found to be repeated, if a code is getting repeatedly used, then that code part will be compiled under just-in-time compiler to overcome the performance bottleneck. And of pure interpretation, just JIT compiles identify hotspots, and we call it hotspots, frequently executed parts of the bytecode. When a frequently executed part of the bytecode is found, it is called as hotspot. It then dynamically compiles this hotspot into optimized native machine code during runtime. That will ultimately save that performance, boosts the performance, saves the time and memory. This native code is cached and subsequent executions of the code path runs at near native speeds. So this how this Java program executes. I will show you in a much detailed way in next sessions. So coming to the architecture, I will show the architecture. So this is the architecture. Java C is the Java compiler and Java source code is Java bytecode. After compilation, bytecode is generated. So after bytecode is getting generated, it get into the native machine code execution. It got into the Java virtual machine, and then if compile just in compiler get triggers, it undergoes just in compilation. So which languages are completely interpreted languages? Python. So if you have ever tried web development, that when we are developing JavaScript and Python, when we are getting error, we will get that error on the spot. So remaining will get executed, remaining part will be executed, but that part will get error and that part will not show any output. So interpreter is used there. Software near projects are mostly used by interpreter, because we are dynamically create writing code and seeing the output. So in hardware, that more compilation is done. So conclusion is both compilers and interpreters are fundamental dispensable tools in world of software development. Final thought: the choice between them is about which is not which is which, and that means choosing a compiler or interpreter means that choosing not which is better or which is not better, not like that. it's like what suits what suits our project, what suits our agenda is more important. So architectures I have shown you. So this is what I want you to convey. Why other languages use other interpreters or compilers is because of their primary agenda of how what they have to develop. So Java is executed in such a way. Now let me show you how this. So leave the C language part, leave the interpretation part. Now only concentrate on how Java is getting compiled and interpreted. So let me show you. I will open a command prompt here. So my command prompt in this is in C drive users folder, and then next Ganesh folder. So I have Java programs folder here. So when I opened File Explorer, uh, when I open this C drive users Ganesh Java program folder I have created. Why my laptop is not charging? So it's okay. I will show that part in next video. A small video on JVM, GRE, and JDK, and this compilation and interpretation execution I will show you in next video. Until then, bye. Thanks for bearing me again. So if you have any doubts, please comment on the below video comment section. If you like this video, please like and subscribe. Thank you.